All right, good morning again. Just 2 more days and I'll be back with you all. But let's do today's lesson. Today's lesson is going to be about talking about even and odd functions and using that in the unit circle. Before we start on that, what I'd like you to do is take a look at these two problems. Try these, then compare with your side partner, and then we're actually going to take some volunteers and have you do those on the board. All right, pause it here so you can try them. Okay, so this, if we draw our picture, which we need to make sure that we do, says go over 8 and down 15. So this is a positive 8. This is a negative 15. Here is our picture. And what is our missing side here? Well, it's a Pythagorean triple, so it's 17. This is a right angle here. So our x is 8, our y is negative 15, and our r is 17. So you should note that the sine of theta equals y over r, so negative 15 over 17. Cosine of theta is x over r, so 8 over 17. Tangent of theta is y over x, so negative 15 over 8. Cosecant of theta is the reciprocal of sine, so 17 over negative 15. Secant of theta is the reciprocal of cosine, so 17 over 8. And cotangent of theta is the reciprocal of tangent, so negative 8 over 15. Okay, now let's take a look at this one. Cotangent of theta is 4/5, and the sine of theta is less than 0. Where is cotangent positive and sine negative? That should be in the third quadrant. Remember that cotangent is x over y. So it says go over 4 and down 5 and draw your triangle. Remember, cotangent is positive, but sine is negative. That tells me both of these have to be negative. Over negative 4, down negative 5. And then we have to find our r. Here's our theta. So how do we find r? Well, r squared is negative 4 squared plus negative 5 squared. Make sure we don't kill any kittens here. So 16 plus 25. 16 plus 25 is 41. So r squared is 41. So r is the square root of 41. Again, our radius is always positive because it's measuring a distance. So for this particular case, it's the positive value of the square root. So what are the 6 trig functions? Well, sine of theta is y, so negative 5 over the square root of 41. Cosine of theta is x over r, so negative 4 over the square root of 41. Tangent of theta is y over x. It's also the reciprocal of cotangent. So if cotangent is 4 over 5, tangent has to be negative 5 over negative 4, which is 5/4, which is the reciprocal of that. If we were to rationalize these, sine of theta would be negative 5. Let's try that again. Sine of theta would be negative 5 times the square root of 41 over 41. Cosine will be negative 4 times the square root of 41 over 41. And tangent would not change. Cosecant, again, is the reciprocal of sine. So it is the square root of 41 over negative 5. Secant of theta is the reciprocal of cosine, so it is the square root of 41 over negative 4. And cotangent we were already given, so cotangent of theta is 4/5. Those are our 6 trig functions. All right, would you get out your unit circles, please? Can you find other angles with the same sine value, sine of 210? Talk to your side partner about sine of 210 and sine of negative 90. All right, what did you find? Right, sine of 210 is the same thing as sine of 330 degrees. Sine of negative 90 is the same thing as the sine of 270 degrees. Are there any other ways to write these angles? We could write the sine of 210 as the sine of negative 150. Remember, we can also, here's my sine of 210 degrees. I could go around the circle one time and stop back there. Has that sine value changed at all? No. So it is the same as the sine of 210 plus 360, which would be the sine of 470. I could go around again. Same thing with the 330. Let's get rid of this picture here just a second. $330 is in the fourth quadrant, about there. There's 330, but I could go around one more time and stop on it, and it's still going to give me the same value. So sine of 330 is the same thing as sine of 330 plus 360. Oh, looks like I can't add very well, can I? This should be 570. Oops. Let's try that again. 210 plus 360 is 570. 330 plus 360 is 690 degrees. And we could repeat that pattern over and over again. Same thing with the sine of 270. We could say it's the sine of negative 90. We could continue going on around and have negative 90 plus 360. So it would be the sine of negative 450 degrees. We could go this direction and go in the positive direction and say here's 270. And then go another 360 degrees. So 270 plus 360. Sine of 270 plus 360 would be the sine of 630 degrees. And again, we can repeat that. Okay? Now, I want you to think about this problem here, and I want you to talk to your side partner about that. What are we doing each time we're going around the circle? So if the sine of theta is equal to 0.8, what is the sine of theta plus the sine of theta plus 2 pi? Think about where that takes you. Plus the sine of theta plus 4 pi. Think about where that takes you. Talk to your side partner about this problem, please. Okay, so if the sine of theta is equal to 0.8, well, that's easy. That's 0.8. But what's the sine of theta plus 2 pi? So here's my angle. Let's say it's here. The sine of that value is 0.8. Now if I do 0.8 sine of theta plus 2 pi, I've gone, there's my 2 pi and my theta, but I'm right back at the same point. So it's also 0.8. Let's think about sine of theta plus 4 pi. There was my theta. There's 2 pi. go around one more time, that's 4 pi, I end up back at the same point. And so my sine of theta plus 4 pi also has to be 0.8. 0.8 plus 0.8 plus 0.8 is 0.2. Oops, how about we add correctly here? Not 0.24, but 2.4. There we go. All right, so I want you to talk to your side partner about what it takes for the sine and the cosine values to repeat themselves. It's talking about the period of the sine and the cosine values. How long does it take before the sine values repeat themselves? It has to be consistent. All right, so here's our completed unit circle. If you don't have this out already, I would go ahead and get this out. Notice here, yes, it's 30 degrees and then I add 120, but is it every 120 when I take 150 and add 120 at 270? Do I have the same sine value? No. If I take 270 and add 120 to it at 390, 390, do I have the same value? I get back to that again, don't I? But every time I go around the circle is when I get back to the same value for both the sine and the cosine. So if I asked you what the period of the sine and the cosine was, the period of sine and cosine says how long does it take to repeat itself? Well, it turns out that the period of sine and cosine is 2 pi. Every 360 degrees, sine and cosine repeat their values exactly. If sine and cosine do that, then cosecant and secant do that as well. They are periodic. They repeat every 2 pi or 360 degrees. We'll talk more about tangent and cotangent and their periodicity at a later date. Other than to notice that they repeat every pi or every 180 degrees, we're not going to worry so much about that today. All right, would you talk to your side partner about what you know about even and odd properties? If I tell you that a function is even, what does that mean? If I tell you that a function is odd, what does that mean? Okay. How many of you knew this? That even functions say that f of x is equal to f of negative x. And odd functions say that negative f of x is equal to f of negative x. What we're really talking about here is symmetry. Okay. What this is saying is that if I take an even value of x or I take the negative value of x, I get the same y values because f of x, remember, y is equal to f of x. What this is saying is when I have opposite values of x, my y values are opposite because this would be negative y and this would be positive y. This would be y equals y. So let's see, just looking at sine and cosine, if you can figure out which is even and which is odd. Look at your unit circle, talk to your side partner about it. If I put a positive x in and I put a negative x in, what value, sine or cosine, gives me the same y value, the same sine value, the same cosine value? Same thing here. If I put a positive x or positive theta in and a negative theta in, what values have them being opposites? If you're not sure, just pick some angles that are on the unit circle. So let's take a look at our unit circle. All right, so for example, the sine of 30 degrees. Let's just look at 30 here. Sine of 30 degrees. What is the sine of 30 degrees? It's 1/2. What is the sine of negative 30 degrees? It's negative 1/2. Does that make it even or odd? Talk to your side partner about that. Same thing with cosine. What is the cosine of 30 degrees? It's the square root of 3 over 2. What is the cosine of negative 30 degrees? It's also the square root of 3 over 2. Does that make it even or odd? Talk to your side partner about what you think. Which ones are even and which ones are odd? Again, think of it this way. Here's my theta. So you can really think of this, f of theta equals f of negative theta for an even function. For an odd function, negative f of theta equals f of negative theta. So there's my theta. Here's my negative theta. Which value is the same for theta and negative theta, and which value is the opposite for theta and negative theta? Figure that out with your side partner here. Okay? Did you come up with this? That sine is odd. The sine of negative theta is equal to the negative sine of theta. Let's use our example of 30 degrees. Sine of 30 degrees was 1/2. Sine of negative 30 degrees was negative 1/2. So is the sine of negative 30 degrees equal to the opposite of the sine of 30 degrees? Well, yes, because the sine of negative 30 degrees is negative 1/2, and the negative sine of 30 degrees is 1/2, but then we need the negative of that. How about cosine of negative theta? Is that equal to cosine of theta? Well, let's think about that one. Cosine of theta, so let's use cosine of 30 degrees. That equals the square root of 3 over 2. Cosine of negative theta would be the cosine of negative 30 degrees. That is also the square root of 3 over 2. Look at your unit circle. Is that true for every value of theta that's on our unit circle? Is the sine of theta always equal to, is the sine of negative theta always equal to the opposite of the sine of theta? Is the cosine of theta always equal to the cosine of the negative theta? Yes, it is. Now you may ask, why are we looking at this? Well, it will help us, or it can help us, when we're doing the trig functions when we have positive and negative angles. Yes, you can look at it on your unit circle, but you can also look at it with this. All right, so sine of negative 45 degrees. It's especially going to come in handy when we don't have a unit circle value. Sine of negative 45 degrees. Remember, that's odd. So that's equal to the opposite of the sine of 45 degrees. But I should know what the sine of 45 degrees is. That is the square root of 2 over 2. So the sine of negative 45 degrees is equal to the negative square root of 2 over 2. Cosine of negative pi is the same thing as cosine of pi. But what is the cosine of pi? Right, negative 1. Interesting. We've thrown in cotangent and tangent. Talk to your side partner about what you think you're going to do with those. Okay, we are going to talk about cotangent and tangent when I return, because cotangent and tangent have a period of pi, and so that makes it slightly different. So for tomorrow, I would like you to look at these problems. Numbers 59 to 75, the odds. But I only want you doing problems if they deal with sine, cosine, secant, or cosecant. So instead of the odds, we're going to make this all. And you're going to skip any problem that deal with tangents or cotangents. All right.